This tutorial will show you how to program and debug ST32 Discover Kit. This Discover Kit has an onboard ST-Link debugger. This is ST-Link debugger. And this is the ST32L 4 processor we try to program and debug it. We don't need any extra hardware except a USB cable to program and debug this chip by using this debugger. Let's look at a demo project. In this project, we have a very simple program, have a main function, and which call find sum function to calculate the sum of integers. To debug the program, we need to make sure we set the debugger correctly. So go to Options for project, click it, click Debug, and make sure we select the ST-Link debugger, and also select Run to Main. And when we start debugger, it will automatically stop at the first line of the main function, and it's selected by default. Go to Setting, make sure the serial wire is selected instead of JTAG. So we use serial wire. In the flash download, make sure we have flash there. And if it's not there, you can simply click Add and select the 1 MB flash. To start the debug, you can click the debug button here. Click it. When the debugger starts, it has 3 windows. On the left, it will show the register values, and here is a disassembly window. This is a C program source code window. And all the debug buttons are here. This is a reset, this is run, step in, step over, step out, run to, go to current position. And we can set a breakpoint. And for example, within the 4th subroutine, we can click Run. It will stop at current position. And we can click it to remove the breakpoint to do step over or step in. And here is call stack will show you the variables names and values. So if we keep step and run this subroutine, and the values here will change in real time. So if we, for example, we can also set a breakpoint here, and or click Run, we'll go to run this position, or we can simply select Run Out. So we're going to execute return from that subroutine. And we can look at the memory values. The memory address of data memory by default start was hex value 20000. See here, we have defined global variable A, so which is FFF, and then a string, and that's 2 global variables. And we can show the value, memory value in different formats. If by right-clicking the window, we can select, so for example, select as a decimal. This will show you as decimal value instead of the default hex value. And we can deselect, we can also select the ASCII. So this will show you the second my string as ASCII value, ASCII strings. And these are dots because they are not displayable ASCII character. And let me go back, show you an unsigned long, and Means go back decimal. No, deselect decimal. Now we're showing the ASCII values. And we can also show, when we execute the program, we can also see variable changes in real time. For example, we just exit from the subroutine, which psum is stored as this is the memory address. The psum is 20038, so we can look at the latter memory value, so 38. So right now it's 0000 because the sign has not completed yet. The sign that we have not signed the return value back to the sum variable. So if we step over, see the value changed to 2D in hex or 45 in decimal. And this is the debug. Another important reason we use Keil is we can see the peripheral registers in real time. And here I'm going to show you an example. And let me close this project. And if we go to the textbook website and download the zip example project here, let's save the project and go to the download directory. And let me unzip it. And open the project. This program just simply light up a LED. So what I'm trying to pull another window or show my web camera to see the board here. This is the board, and I can set up breakpoint here. This program just light up a LED. It specifically light up set the GPIO pin B2 to high. If you look at schematic program here, see PP2. If PP2 is high, LED 4, which is LED red, will be on. So I can set up a breakpoint, any breakpoint here, and start the debug. This shows I made one mistake because I haven't compiled my project yet. So now I can debug it. And I click run, it will stop at the breakpoint. Again, the very nice feature of this program is the MDK in debug environment, because I can see peripheral register values in real time. For example, I click peripheral, system viewer, and GPIO B. So this is GPIO B, and this is mode register, and I'm setting the GPIO B2, the mode as 01, which is digital output, and output type by default is push-pull. 0 is push-pull. It's not selected 0, it's selected, then it's 1. And output speed of GPIO 2 is 00. And also, most importantly, because we have set it as a digital output, we look at ODR, output data register here. So this statement is trying to set ODR2, which is here, as 1. So let's run this statement. See here, the LED is on. Then our output data register 2 is selected because it's high. We can, for some registers, we can also change the value in the debug environment. For example, output data register, if I click it, it will set to 0, the LED is off. And if I click it again, and this is will be on. So you can see many other peripheral registers, such as RCC, and other GPIO ports, and also the core registers, including system tick timer, so you can see system timer value, and MVIC, so all the interrupt, you see whether the interrupt, whether they're enabled or disabled.